Sorry, I'm jumping around here a bit. So let me back up a touch. Well. That's where I want to be. Let's see if it'll give me a cursor option. No. Okay, so basically, just getting back to the differences there. The storefront being a flush glaze system, essentially the glass, the framing members are one complete member, front to back. There's not a case in these storefront systems where you've got a back member, pressure plate, and cap. It's basically one extrusion for the head, sill, intermediates, and your jambs, whereas the glass goes into a pocket, gets set into place, and then it's kept in place with glass stops. The systems are 1 3/4 inch, basically, if you're using a 6 mil infill for interior applications, and 2 inch sight lines being the width of the product that you would see when standing in front of the elevation is standard 2 inch. The typical depth of a storefront is 4.5 inches, and there is 6 inch systems as well to try and fit deeper wall sections. They can be glazed with the glass tops on the exterior or the glass tops on the interior, although I don't know why you put the glass tops on the exterior, because it could potentially create a security problem. Dry glaze, so rubber neoprene gaskets inside and out up against the glass. And essentially, storefront is designed for small spans, basically 10 feet or less, and also can be glazed, whether it's in the front, the middle, or the back of the frame. And we'll get more into that as we go through some of these slides. Okay, there we go. So the systems come in a thermally broken system or non-thermally broken. Obviously, if we were dealing with something that was non-thermally broken, it would be an interior application. And the storefront systems are designed to be non-thermal for those reasons. That way you can match up exterior framing components with an interior vestibule or whatever you may be drawing within the lobby area. And obviously the red highlighted area on this slide is showing where the thermal break is within that frame. In case of a storefront, you're basically taking an extrusion like you see on the right-hand side here and filling that pocket with a resin component, and then cutting away this leg after that pocket is filled, creating a thermal break between the two pieces of aluminum, which at the time of extrusion and finishing were one. So that's how a storefront system is given its thermal break or thermal properties within that aluminum extrusion. As I alluded to in that first slide, the difference, one of the differences between storefront and curtain wall is the span. So if you're looking at an opening within any of your building projects that is 10 feet plus or minus a little bit high, you can look at a storefront product. Once you start moving into rough openings and elevations that are exceeding that 10.5, 11 foot mark, then you're automatically going to be considering a curtain wall product. One of the quick ways to determine what you want to start looking at as far as product application on your build. Sorry. So another key component with storefront systems. The storefront system is not a pressure equalized, rain screened application glazed opening. You basically have a frame that's being put into an opening, as you'd see in this slide. The perimeter up against the stucco in this case and the aluminum jambs and heads and sills is siliconed inside and out, and essentially prime sealed. Any rain and water that's driven at this elevation and enters the system basically the horizontals will guide it to the vertical, and all the water that may be collected by these horizontals within the glazing cavities are all diverted to the sill and out of the building. The difference between that and a curtain wall is a curtain wall, every one of these daylight openings handles water on its own. So every daylight opening in a curtain wall is drained on the horizontal below the piece of glass. And it just becomes a tighter air seal and a tighter wall air water-wise for sure. So again, this is just showing the drainage path of the storefront. As I alluded, the water collects any water condensation that you may get sitting in this cavity under the glass, diverts to the vertical and all the way down the system and out of the framing system. So if you had a north-facing elevation, northwest-facing elevation, and you had say it was 10 feet high, and wanted 3 or 4 horizontal members in that opening, you're creating a lot of area for water to collect. And on a heavy rain day, which we can see in southern Alberta, a system like this would probably have more water running in it and trying to get out the sill than it could handle, and therefore would probably end up inside the building. There are ways to combat that with different sill flashings and whatnot, but it is one of the things that with a storefront system, we should always be considering what elevation is it facing, how susceptible to driving rain is it, and how many horizontals are I putting in that system, adding a water collection point with each horizontal that's added. So just one of the things to keep in mind. Just a little section, cut through section, plan section of storefront, and it's called Trifab in our glossary, if you will, for the reasons that it can be glazed in the front plane of the frame, or the back plane of the frame, or the center plane of the frame, and that's why it's called Trifab for those different options. So depending on what aesthetic look we're looking for, and also where in the wall cavity we're placing it to line up our thermal breaks with whatever is going on in the building construction around us. This option can be used to move the glass plane to the front, to the back, or keep it in the center. The center in a storefront is probably the one used 99% of the time. So, curtain wall. Again, you're looking at, if you walked up to buildings and, saw an elevation that's 10 feet high and, had 13, modules at 1,200 widths running down a building, and you looked at it, first glance, it's kind of tough to understand, is that a curtain wall or is it a storefront? So the curtain wall, to start with, in its made for application, is a non-load bearing exterior wall. So realistically, a complete envelope that's designed to, go around the building on all elevations. It's only designed to carry the load of the metal and the glass itself, and any add-ons that you would see within our catalog, for example, sun shading products and whatnot. If you ever have elevations like you see in the bottom right, and there's a requirement to have signage on that curtain wall, it's extra engineering that needs to be done realistically by the sub-trade or glazing contractor that's doing that work. It's designed essentially to run on the outside of the floor slab versus slab to slab, but there's many applications where it is run slab to slab as well. Again, compartmentalized DLOs using pressure plate and cap assembly. And just a note, in all applications, and we'll get into that when we talk about thermals, that the more glass you have on an elevation, the better the thermal performance is overall. Curtain wall, as we discussed, is used for larger spans. And primarily, if you were looking through my product information on a curtain wall product, you'd see back in the pages some span graphs and understanding, okay, how high can I have this vertical member span based on how deep it is without it failing. And you'll see areas where they talk about twin span and single span. Twin span, anytime you hear that application in the glazing industry, at the very least, is something where I'm sitting at the sill and I'm spanning the floor slab into a second floor application, with the understanding that my anchoring points would be at the sill. I would have another anchor at my second floor, or my line of my HSS steel, and then another anchor at the head. The anchor at the sills are referred to dead load anchors. the anchors at the midpoint and the head are considered wind load anchors, and they're not carrying load of the system, but they're stopping the wall from deflecting laterally under wind load pressures. So, I mean, obviously, if I was looking at a system and my span, in this case, is 10 feet, and I'm gonna, just as an example, I'm only anchoring at the sill and in the head of a vertical mullion. This is an intermediate, not so much concerned with a jam condition, but certainly intermediates for sure. 10-foot span at a certain wind load, 30 PSF in this case, the middle of that mullion has the opportunity, depending on the size of it and the span and the load, to over deflect. And if you had a vertical mullion over deflect to that degree, obviously, you'd have glass falling out, breakage, and catastrophic failure. But the max that system, in that case, which is an overall 6-inch system in this example, 3 3/4 inch back section, will allow you to span basically 10 feet anchored head and sill at 30 pounds lateral wind load. If I introduced a midpoint anchor in there in any application where we're very close to a mullion's capabilities, that same back section of 3 3/4 inch deep is now capable of spanning 23 feet versus 10 feet, just because we put that HSS steel in there. So it stops that midpoint anchor from over deflecting, and you can create larger spans by giving the tiebacks in the structure for your curtain walls. This is the chart I was referring to that you will find in all the manuals for curtain wall, windows, and it's basically giving the design team a cursory review, I guess, of what back section within a specific system will do what for me. And if we were looking at this chart based on the example on the previous page, we basically would see that, under a 30-pound wind load, which is this B line in the graph, I would be spanning at 5-foot module width, so that's the dimension between my vertical mullions, maximum 10 feet high in a single span application. But if we look at the twin span where I've got a midpoint anchoring, that same back section is all of a sudden now capable of getting up to 23 feet at a 5-foot wide module. So quite a difference when you give a little bit of support to a curtain wall in what you can do for spans. Again, why use curtain wall? Obviously, as far as modulus of elasticity, if you will, in comparison with steel, which is obviously very high, but it has no thermal properties, and it's tough to deal with from that standpoint. Aluminum is the next best thing in comparison to where your fiberglass may sit, or PVCs and vinyls. And that's why aluminum is one of the most commonly used items in commercial building products. Certainly, you cannot beat fiberglass and PVC in respect to the thermal properties that they provide, but from a structural capability and a span, deflection properties, etc., that's where you start running into problem with those items. Another great thing, one of the biggest things with curtain wall over storefront, especially in territories like Calgary, Edmonton, Winnipeg, Saskatoon, climates where we have extreme cold and can have extreme heat at the same, not at the same time, but in a course of a few hours in southern Alberta for sure, expansion and contraction is constant within commercial glazing products. If you remember my comment about the storefront being a prime seal, the verticals, jams, the heads being up against the rough opening and just caulked against that rough opening, you're relying on silicones with expansion and contractions, and the cold, we find that a silicone will break down, and then you've got air and water problems, which is, the worst thing that you want to have happen. With curtain wall, you actually have a continuous air seal from the building into the frame. So we're not just caulking between the jam and the head to the building. We're actually tying in air seal and components, whether it be peel and stick, blue skins, right to the building exterior air seals. So you have a continual air seal off the building sheathing right into the glazing system and out the other side. These air seals, here's that slide, out of order a little bit. But I mean, if you considered a curtain wall plan view at a jam condition like I'm showing here, a storefront would just have this caulking bead in the front and in the back. With curtain walls, whether it be air seal tie-in that's on the exterior of the sheathing coming back and into the shoulder of the mullion, or if it's reminiscent of maybe a residential application where the air seal is coming from inside to the shoulder of the mullion, in any case, the air seal is mechanically fastened to the shoulder of the mullion, siliconed, and mechanically fastened. Therefore, it's not going to tear away, break down, and you never have to be concerned about this silicone joint breaking down 20 years from now. You do not have to worry about air and water coming through that area because of that tie-in. And that is probably one of the biggest thing to remember between curtain wall and storefront is that ability right there and the benefit to it. And if you see to the point where if there's specifications out in the industry for tender and their storefront specified, a lot of the glazing shops and subcontractors are going to be sending in RFIs to add, or requests to change to a curtain wall product for this reason specifically. So some different curtain wall framing options, because there are some. We basically, you talk about stick build curtain walls where guys are coming on site and putting the frames in, glazing them after, to unitized systems where the curtain wall is showing up already glazed in frames and being hoisted up the building and being installed. A stick-built system, if you're familiar with some of the products, and I think the 1600 UT you're starting to get familiar with, is a stick-built system, or shear block applied for joinery. When we talk about shear block, we're talking about this little piece of aluminum that gets fastened to the vertical mullion. The horizontal slides over top of that and gets screwed to it, and that's a stick-built system. So tubular mullions, shear blocks, and horizontal sliding on. And they basically build those depending on the elevation, sometimes in their shop, but if it's large, it'll be done on site. Vertical mullion, horizontals, another vertical mullion, next horizontal, and so on. The other type of stick-built curtain wall system that you can encounter is a screw spline. So rather than having tubular vertical mullions, you've got an open vertical mullion that has got a female and a male half. So basically, you're just running screws through clearance holes in the vertical into screw splines into the horizontal members, and that's how the joinery is done. These types of systems can be pre-glazed, and there's certain applications where they're used. Predominantly in Calgary, you see all of the first system being used, the 1600 UT with the shear block. If you were on the West Coast, you'd see mainly this system used. And it just really, in a lot of cases, comes down to preference and in some cases design. Another curtain wall system that you will see on large projects where you've got consistent panels. Consistent panels is the key when you're looking at any unitized system. If you had different openings with different module widths, different module heights, stick build is the way to go. These are very cost effective when you've got consistency on all four sides of the building up the floors, and not so much when it is inconsistent. These projects are fabricated and machined in the shop, pre-glazed, come to site, and basically you start at the bottom, working left to right, and stack them on top of each other all the way up the building. And I'll give a couple examples of these jobs that are in Calgary if people were interested in seeing them firsthand. Another product that falls under the curtain wall in the website, but acts more like a storefront, if that doesn't confuse you, It is used primarily in your residential condominium towers. Other products and manufacturers that have that are playing this market, be Toro windows and Starline windows, do quite a bit of work in the East Village area of Calgary for sure. This system is designed to be installed between floor slabs, but has at the sill and at the head the ability to have a slab bypass panel. So it bypasses the slab and then works back into the wall all the way up the building. They all install from the inside, so you don't have to be up on swing stages doing any work from the outside of the building, which is very advantageous. But are designed more like a prime seal where everything diverts to the sill and out. Now, because it is only installed slab by slab, you typically are dealing with dimensions of 9 to 11 feet max. So it's really something that works in those conditions, drains at every floor slab. Getting out of the main building envelopes and just touching briefly on some of the products, other products that you'll see coming out of that same scope and out of our facility and company would be your commercial doors. If you went to my website, you'd find quite a variety on there, from standard doors to something called an Insuclad to something called an Insulpor. If you're looking at any door to specify on any new build with today's new code, you're pretty much only going to be looking at that one. None of the other doors should be specified because they are the furthest from the code that you can possibly get. And this is a true thermally broken door that can accept all sorts of custom hardware, standard hardware, up to 9 feet wide, 9 feet tall, 4 feet wide, pardon me. And again, as I said, in your projects, this should be the only exterior entrance door you're looking at. So that might bring up some questions later. Operable windows. Again, website will give you quite a variety. I always promote and try and get specified the items that I'm building in Lethbridge for a variety of reasons versus, say, in Pennsylvania. This window here, the AA6400 series, you'll see on our website. It has fixed framing. It has an operable window package where it's top hung, project out, side hung, project out, bottom hung, project in. Typical configurations that you'd see in your home. Very reminiscent to the vinyl window profile that you would have in your home. Obviously can be made larger because it's aluminum. And these windows can be installed into a window frame, into a storefront frame, and into a curtain wall frame. So anytime you're looking at operable windows within your building, this is one that you should consider for sure. And it can be double and or triple glazed just by changing in an interior glass top, pardon me. This is the next window that is getting a lot of traction. Again, code driven, mainly because its thermal properties are better than the AA6400, and that is mainly because this window has got no real exterior aluminum frame to it. The glass is either structural silicone or 3M taped to the back section. So therefore, the only exposure to the cold is really the face of the glass. The part at the head and the sill is a non-thermal polyamide type product. So basically, this window is another great option for a project because you don't have the separate frame and sash that you see here on the 6400. You basically get a clean, equal DLO look from your fixed window to your operable window. So you're getting a clean aesthetic look without a buildup of a frame in this area, and a good thermal product as well. After all that's said and done, and we've gone through differences of curtain wall, storefront, some windows, doors, it's like, okay, that's good information. But if I'm looking at a project, where do I start? How do I know what what to choose. Where do I start? So I thought I would just throw together just a quick spreadsheet, just hopefully sort of identifying some of the key determining products that when I'm reviewing a project, the first things that I'm going to look at to fine tune that assessment, if you will. So right off the bat, when I'm looking at any elevation, the first thing I'm doing is looking at frame height. And as we've talked about for storefront, if I'm 10 feet under, that could be a consideration. And if I'm over 10 feet, it's curtain wall, right? So it's curtain wall or storefront, just from that standpoint. We talked about curtain wall being installed in different manners, primarily designed to be proud of the slab and creating a full envelope. So if that was your design intent, then you only have one choice, curtain wall. Nothing else is on the table from that standpoint. If you're dealing with punched openings within your building and or any conditions where you've got a jam in a head and you're not really creating the exterior envelope by the curtain wall versus filling an opening, you're down to you can go curtain wall, storefront, and or a window product. But again, what's your heights, right? If it's under 10 feet, then you can look at the storefront and the window products in here. But if it's over 10 feet, you're still destined to be using a curtain wall. Does it have swing doors and entrances or entrances within the elevation? If it does, curtain wall, storefront are your only options. None of the window products that you'd see on my website have the ability to have an entrance hanging off its jamb, if you will. Operable windows fit in all three product groupings. Is it double glazed or is it triple glazed? And again, sort of coming up with your overall performance requirements, because everything can be manipulated to meet certain performance numbers that you need for your building. But right off the bat, just understanding if we're dealing with a triple glazed application or double, the storefront does not have that application available to it, but your curtain wall and your window products do. Talking about thermal requirements and performance requirements on your fenestration is I guess can be a very in-depth conversation. We know right now within Alberta that the code would specify that all your fenestration will be no greater than 1.9 watts per meter squared and or 0.32, 0.33. I guess 0.33 BTUs is what it is. Every architectural detail manual you will find for every product that I have in my portfolio, you will find towards the back of the book, after the details, you'll find the thermal information, and every one of them will have this thermal matrix, which allows you to briefly look at, okay, if I need to be at that 0.33, 0.32 number, what do I need for glass? Oh, I need glass that is going to perform to a winter nighttime U value or center of glass performance number of 0.24. I apologize that these are all in imperial, as I'm an American company. But in any case, these charts tell you right off the bat what system you need to hit a performance. If you're doing a new build, 1.9 is automatic. It could be more aggressive than that, depending on how your modeling is coming along, right? But 1.9 is cannot exceed that. End of story. It's got to be equal to or greater than, depending on your trade-offs, right? So these charts will give you a good indication of, okay, what system, if I'm looking at curtain wall, do I need to start with? If you looked at this example that we're using here, is the 2-inch ultra thermal curtain wall with aluminum pressure plate. If you looked at the standard 2-inch curtain wall, which does not have the ultra thermal UT behind it, you would find that you can't hit code with that system unless you started going very aggressive with glass and putting fiberglass pressure plate on it to reduce the thermal transfer. So the thermal requirements, the performance numbers is part of that breakdown that we had looking at on the in this breakdown when you're trying to understand what product to do for sure. pages ahead of myself. And again, sorry, just to back up a little bit on this thermal matrix chart. These charts are also based on the test specimen size, which basically all manufacturers that are producing systems are testing to, so that apple to apple comparisons are made. So if you looked at Lumicore's product, Oldcastle's product, Kawneer's product, they all are testing to the same ASTM number, and it's designed based on a certain sized frame, and that's the number that's coming to. Those are typically the numbers that anybody that is, I guess, approving permits and whatnot, and is all the numbers they want to see. There are methods to go through the specific project and do actual thermal calculations for every opening, and that is another. Again, that would be a separate presentation altogether, because there's definitely takes a little bit to get your head around percent division, which is, glass versus metal ratio, and how that changes the performance of the system by changing your elevations. With that said, it's always good to get the best performance out of your design is to have the largest lights of glass that you can. The more metal you overload a frame with, which I love because I love true divided lights and I think it looks great. But again, the more metal that goes into the system, the more you're negatively impacting the ability for that frame to form to even the test data number of 1.9 watts. So it's important that we maximize our glass sizes the best we can to get the best performance out of any system. And I think I did put a note. Oh, I didn't put it on this, but I did make a note that in respect to glass size, if we say maximize our glass size to get the best performance, well, what is that glass size, Paul? You can get very, very, very large pieces of glass, but you have to go either into the States or overseas to buy it, which obviously costs money. And then there's the logistics of getting it here without damage, and then replacing glass units 10 years down the road. Where did we get it? I don't know. Versus buying local product, I guess, that's available in Western Canada through the companies like PPG, Vitrum, Oldcastle, and guys like that. And if we were considering what their maximum is, it's basically about a 65 square foot number. So I think the number that I was looking at earlier when I thought I made a note on my page. It's 60 inch by 156 inches. And if you obviously the wider you go, then that 60 inch has to go down to that 65 square foot number roughly. But that would be the max glass size that you would find locally for sure for your elevations. For anybody that doesn't know it, I'm sure you all do, but Kawneer.com is a public website that everybody can have a look at and go through. Every product that we talked about here today is on those, and then a lot more. The website would contain, obviously, under every product group, the architectural detail manual, which has, rough, just preliminary details to give you an idea of the product, but it has, the wind loading charts to understand back section depths. It has the thermal information, and obviously different information giving you an overview of the product. As well, CAD details are all available within that website as well. So if there was anything within, detail-wise that you were looking to grab, they are available off that website as well. Last but not least, I guess we'll open it up for questions. I did want to mention everybody, and I know this may be a loaded gun, but there's anytime we're going through fenestration, it's not something that is just you see it once and everybody understands exactly what's going on. So I did want to leave my email address on this last slide as well. And if people are, as they're working through their projects, if they do come up with a question or a head scratching moment and just looking for a little bit for clarification, I'm more than willing to receive those emails and try and help out where I can for sure. With that said, I will open it up to whichever questions we may have.
Feel free to unmute yourself or to put a question on the chat box.
Hey, Paul. I'll ask a question. That max glass size, like it's 65 square feet. Like, is that common, or are we usually more around 45? Because I seem to recall being limited at like 35 to 45. This is several years ago, though.
Mm-hmm. I know that depending on what the application is, like if you were doing a four-sided SSG application versus captured, then you run down to around that 45 square foot mark, and it really comes down to glass weight, adhesion factors, silicones versus pressure plate and cap application.
Okay. Thanks.
But that number, the only reason I'm confident in that 65 is I went to one of my customers because I was working with an architect on a project, and that was one of the questions, and I wanted to make sure I had my answer right. So I went to one of my guys to understand exactly what locally he could buy, and that was the number.
Okay, good. That's a really good information for our students, because they like to make massive glass panels. So we like to say, well, you can get them, but
yeah. But if you can get anything. Like I always say to everybody, anything's possible, but how much money do you have?
Yeah, exactly.
So I've got a question here. What is the spacing for midpoint anchors typically to prevent stress? So typically, I mean, it's really, that 10 feet, 11 feet mark is sort of where you're at, but it really depends on, whether you're using a back section that's 3 3/4 inches deep, 5 1/4 inch deep, or 8 1/4 inch deep, or 10 inches deep, because they are available, right? So, the biggest thing, if we just went back, I'll try and see if I can find that chart real quick, just to give another explanation, a little bit maybe clearer explanation on that. So if I look at this again, this is based on just a standard walled 3 3/4 inch curtain wall back section, and in this case, during with the spans that we're seeing there, you can see that from 5 feet at the 5 foot wide mark, giving us the ability to get to 23 feet. You add a foot to that, and you can see how much that drops. It drops 2 feet, for every width you get in that application, right? But it's going to depend. There's really not a typical answer to that, because every project can be susceptible to different lateral wind loads. So I always go back to design team at the time of trying to understand mullion spacing and back section depth, is like, what are you anticipating for lateral wind load? Are you anticipating 23 pounds per square feet, or are you looking at 40, right? There's areas of Lethbridge, the University of Lethbridge, the corner of that building was running at 50 to 55 pounds per square foot lateral wind load, versus, say, in downtown Lethbridge on a one-story building being at 23 pounds per square foot. And that's, that is the key for me, is what's my lateral wind load, and that's going to determine how wide I can space those mullions based on how tall my opening is. Does that answer the question? Thank you.
Sorry, I just had a quick question on, you mentioned prime sealed for storefront glazing systems. What does prime sealed mean exactly? Basically,
it's basically just you're plugging the opening and fishbowling it and caulking around the opening, versus any kind of air membranes being tied into the framing and cleaned up that way, right? It's basically just relying purely on silicone, and there's no pressure equalization or rain screen principles being applied to the wall. Whereas curtain wall is, because you've got a solid air seal all the way around, and drainage cavities within it at every horizontal, it allows water in, but it's designed to bring it out. And with the mechanical seal of the air seal all the way around, you just have an impenetrable air and water seal at the end of the day. So prime seal is basically just caulked, installed and caulked.
Okay, perfect. Thank you.
Oh, I got another question.
Mm-hmm.
You didn't really show any SSG mullions much there, but is there any mechanical fastening at all for that glazing panel, or is it purely just structurally siliconed?
So with the SSG systems, let's see if I have that open or not. There's two different things going on with SSG systems. There's the traditional structural silicone glazed system, and then there's our current product line called Clearwall, which relies on a mechanical system but gives the appearance of a traditional structural silicone glazed system. So if you were like traditionally, if you look at my systems, the Kawneer 1600 System 2, which you'll see on the website, is exactly the same as System 1, which has got pressure plate and cap on all four sides, versus the structural silicone glaze system in my portfolio, which has got either two of the four sides are capped. The horizontal in a two-sided, when I'm dealing with a vertical SSG joint and my horizontals are capped, that vertical typically is just silicone, no mechanical fasteners. If I was to provide that same system with an SSG horizontal and an SSG vertical, basically they, in a traditional application, are just siliconed on, no mechanical fixing whatsoever. There's a chair on the horizontal extrusion that the glass sits on. The glass is placed into the opening. They use a temporary, what they call Dutchman clip, or a temporary glazing clip, to keep the glass in place, and then they pump the void full of silicone, let it cure, and it's just glued on. If you look at my Clearwall simulated four-sided SSG application, that system can be installed one of three ways, and bear with me. The first and primary way that this installation works is the glass is designed so that the spacer between the inside and the interior and the exterior light is recessed back from the edge of the glass about, I think it's, don't correct me, 7/16 of an inch, if you will. So that recessed pocket that the recessed spacer creates around the perimeter of that sealed unit allows the Clearwall to have a mechanical screw go into the back section and then a plastic metal combination toggle that turns and engages up against the inside piece of glass, pushing it against the back section, sitting in that pocket that the recessed space of the glass has created. Did everybody follow that? So it's essentially mechanically fixed, but once it's done, it looks like it's just a non-mechanically fixed piece of glass installed. That's Kawneer's four-sided SSG in a stick-built application. Okay, if I took it to a unitized curtain wall, like we showed in one of those, come to site fully glazed, those systems are completely just glued on. The glass is glued onto the frame, period. It's done in a shop with very clean conditions. You control the environment conditions, the dust, and everything else. So there's a process of cleaning, siliconing, and cure time that the system goes through, and testing obviously like crazy, right? Because you're hanging glass off of metal 40 floors in the sky, in the air. So you don't want that falling off. But yes, there are many applications where it is just glazed by silicone adhering to from the glass to the metal.
Paul, there is a way that you can share a detail of this SSG coding work for the students to understand much better?
Yes. So when I change, if I don't, I'm going to see if I can change my share screen here. What are you guys seeing on my screen right now? Like,
It's the presentation. We are in the span charts.
oh yeah, okay. Let's get back there. See if I can change this out here. I'll just show you. Do you want to see the toggled SSG system or the vertical SSG application where I have capped hoprizonals? What do you want to look at?
Either or. It's
Okay.
mainly for the students to understand much better
Okay.
what you were explaining.
Let's have a look at both actually, because it won't take long to throw. I'll just get the files open real quick here.
While you're doing that, can I just ask a simple question?
You betcha.
You've got your anti-rotation bar in the throat of the frame where there's no glass, right?
Yeah.
Sometimes I see a rigid insulation in there. Like, is there some magic to which one goes there? Like, if the membrane's mechanically fastened, do you really need the anti-rotation bar?
Yeah, you need the anti-rotation bar because it's not there to hold the membrane in. It's there to keep the pressure plate from negatively rotating into that empty pocket and then not having the pressure of glass, gasket to glass, on the glass side of that vertical or head or sill. So you need to make sure that pocket's solidified with something that's not compressible, so that the pressure plate stays on the same plane on the glass and on the pocket side.
Okay.
So,
so is rigid insulation possible, or is it?
Yeah, rigid insulation works for sure.
Okay.
There's a lot of the guys are moving to. There's a company in town that I try and direct them to. That's, I think they're called Flowform, but they extrude polyimide or ABS PVC type tubes and channels, right?
Yeah.
And they do variety of sizes, right? And that pocket, the size of the blocking that you need varies, right? What's getting tied into that pocket? You've got, maybe a blue skin, a mechanical bar to fix the blue skin to the back of the mullion. Maybe you've got a flashing tying in there, right? So the pocket depth can vary where an aluminum extrusion isn't always going to work, because it needs, maybe it's a 16th inch narrower today than, because of this detail, than it was on the last project. So they, and plus those PVC parts that this guy extrudes are non-thermal, right? So it gives a lot more comfort to a lot of design teams to see a non-thermal anti-rotation block in there versus a piece of aluminum. Yeah, even though it's on the cold, the cold side, and my testing data would have me tell you that it's a negligible point, but in this climate, I understand why people would want to see a non-thermal part in there versus a piece of aluminum, without a doubt.
Just looks prettier in pictures, right?
Well, it does, and it's not, metal. Aluminum gets cold when it's cold, so
yeah, it's not really doing much. Yeah. Okay. Thanks.
Yeah. Let's see if I can get this page open here for us. No, that's not what I want. Sorry, I was trying to get one of these Clearwall windows open here, and I'm struggling to get it to share. Wonderful. Let's see here. I'm not sure why I'm not able to share that screen. Oh, let's see what this does. I'm just freezing my computer up now. I don't know why. Yeah, I should have included a shot of that SSG mine in that presentation, and I apologize for not doing that. I don't know why it's not allowing me to share. I'm going to see if I've got something else going on here on that. Try and explain just a little bit through this one page here, the difference between an SSG system and a captured system. But essentially, if we look at this stick-built curtain wall system, and you've got your vertical member having the pressure plate and cap, and obviously the horizontal shows the assembly of the back section, the pressure plate, and then the beauty cap that covers the pressure plate. And we understand that that pressure plate is designed to capture the glass into the glazing pocket and hold it there. So in a two-sided captured, or our 1600 system 2, what you would see is the horizontal still having the cap and pressure plate to hold the glass, but this vertical member would not have, obviously, the cap and pressure plate, nor would it have the nose or assembly. The whole front face will be flat, where the glass basically sits in the same plane. The glass bite, meaning the dimension the glass travels into the frame, is the same at a 1/2 inch per side, but there's just no nose there. So when the glass is put into place and the customer applies the pressure plate head and sill, the same thing as happens on a 4-sided, they go to the inside of the building and they will caulk the gap in this area with structural silicone, which will then be allowed to cure to adhere the glass to the vertical member. Then on the outside of the building, where the two exterior pieces of the glass come together with a joint of maybe 3/8 of an inch in that ballpark, then that joint between the glass all the way back to the inside of that sealed unit is pumped full of structural silicone to give you that exterior seal, rain seal on the exterior of the glass. But the primary adhesion factor comes into play when the silicone is adhered to the back member on the inside of the glass. One of the biggest drawbacks about having a structural silicone glazed system is if glass breakage occurs and you have to go and replace glass. You're not just popping off cap, unscrewing pressure plate, removing the piece of glass, and then putting a new one in. You're having to deal with structural silicone adhered to glass and framing that's potentially broken. You have to cut it away. You have to clean off all that silicone, re-clean it with, a decent high flash point alcohol-based cleaner, and then re-silicone and glaze. So there is that to dealing with a structural silicone product as well. But I encourage you all to go to the website maybe shortly. Then I apologize for not being able to get my screen changed there, but just look at 1600 System 2 and see that, this same isometric drawing will show up on page 2 of that manual, and you'll see where that vertical member is void of a cap and pressure plate. And if you flip through that page and look at some plan views, you'll see the difference there. And then from there, go and look at the clear wall, curtain wall, and see how that system is mechanically fastened but still looks like a structural glaze system. But the recessed glass for the clear wall is not a inexpensive venture. So I traditionally end up selling a custom system too that can be applied traditionally with temporary glazing clips and gasket, just for the side note. Have I confused everybody completely with that explanation?
Don't worry, it's all Darren. It's all Darren's fault. He asked the question like 20 minutes ago.
No. I only asked if it was actually just glued. And
I know. I'm sorry.
He just blew it out of the water there, saying, "Show us this stuff."
But it's a bit of a. When people start talking about structural silicone glaze systems and 3M tape, it's hard to believe, that you could be looking at a project that's 40 stories tall and realize that, man, that's all glued in. Like this picture here, these on this slide, this top picture is a project just on Blackfoot, just before you get to, I believe, I want to say Heritage, but it's called Meadow Miles. And this is a stick-built curtain wall system, and it's got a combination of 4-sided captured lights in this elevation, moving to 2-sided to nothing. It's a real custom application, even though these lights are just into, nothing, huge. This bottom left-hand picture is of the Eris podium that's down on Memorial downtown. This is a partial picture as it was being done. And this elevation and the other side of the building is all the 4-sided clear wall with ginormous pieces of glass in it, if anybody's interested in driving past that project. And then this project, even though it's a rendering, is the 3 towers of West Village. One tower being this here is complete all the way to the top. This tower is in process of getting glazing, and the third tower is not out of the ground yet. But this is an example of a unitized system. 2500 UT is what's being installed on that job. The architect is Kawneer, and the developer is Sidex. And the glazing contractor on this one is Custom Metal. But this is 4-sided SSG glass adhered to the frame in the shop, delivered to site, and then craned up and basically stacked and installed and anchored into place on this job. It includes balcony doors for the swing doors on the balcony and operable windows, as it's obviously a residential condominium. So that's an example of a 4-sided SSG unitized system locally that if people wanted to look at, they could. And again, I do want to mention to everybody, like I think you guys are in the process of working on some projects. If you do have a question, if there's something's come up out of here that's related to your project and you're not, you weren't fully clear on what I was trying to relay, because as I said, I can go on. Please don't hesitate to shoot me an email. I'd be more than happy to respond. And I found this little picture I added onto the side of the presentation this afternoon, and it's a copy of what the installation instructions looked like about 30 years ago, and they were basically hand-drawn and handwritten, and there was no AutoCAD, and everybody was doing shop drawings and everything right off of drawing boards and pencils with electric razors, and that's all I heard all day were those little electric razors buzzing, erasing mistakes. So if anybody has any more questions, feel free to ask. Otherwise, I appreciate the time today. It's always a pleasure, talking about these systems and how they're applied. And again, if anybody has any further questions later than this, feel free to ask. And if Amanda, if you want to copy this presentation, I can certainly send it to you via email.
Oh yeah, I was gonna ask that actually.
Yes, I will for sure. Yeah, I'll include those. I'll include that information as well, and I'll try and take some shots and just bubble up and highlight those differences. Awesome. Well, you all have a great weekend. It's Friday, and like I said, the sun's still shining down here, so hopefully it is there as well. Cheers. Right on. Thank you very much. Bye.
Thanks, Paul.